So we have started from factors affecting the rate of evaporation. The first factor is temperature of the liquid. When the temperature increases, the rate of evaporation increases. Surface area of the liquid. So when you take a bigger surface area, I mean a wider surface, rate of evaporation will be faster. For example, on the surface of an ocean, evaporation is much faster than a river or a canal or a lake. So greater the surface area, greater the rate of evaporation. So now copy this. Number three. Number three, drought over the surface of the liquid. What drought has to do, it is like the wind, it is like the air. The wind blowing over something can evaporate quickly. So for example, if wind is blowing faster, this is a still air surface and this is a windy surface. So when it is windy, it will actually cause rapid evaporation. So in case of faster wind, you will get quicker evaporation. You have to copy now this. So this is to copy. Number four, humidity. What is humidity? Humidity is the moisture content in a medium. So if air is humid, it means it contains moisture a lot, and then evaporation will be slow. So in humidity, the rate of evaporation decreases. You have to copy this. Difference between boiling and evaporation. You have to now copy this. Now, boiling and evaporation have some differences. Boiling take place at a fixed temperature, boiling point. Evaporation can take place at any temperature. Boiling takes place throughout the liquid. Evaporation takes place on the surface of the liquid. Bubbles are formed in boiling. Bubbles are not formed in evaporation. So this is the point to remember. This is the point to remember that there is a contrast between boiling and evaporation. Now, this is only a matter of memory. I will post it there on the group, and I will put a reference number there as usual, as we did before also. Remember that boiling and evaporation are technically different. Even both of them are going to produce a gas state. Now, what is the what is the reference number now? We haven't put any reference number yet. Actually, reference number method is there. When I put a picture, I put a reference number, but I think I haven't started this thing here because it's not coming in my search. Acha, reference number means that I put something on the chat. People told me that after putting it there, after few classes, it's always lost in other chats. So I put a reference number. Now you have to give the heading. Acha, after giving the heading, write under it reference number 1. Write under it like this, reference number 1. Now give the heading, similarity between boiling and evaporation. Give the heading, similarity between boiling and evaporation. They both involve a change of a state from liquid to gas. They both involve liquid to gas. You have to copy this. You have to copy this. So evaporation and boiling have one thing common. They both involve a change of a state. Now this chapter is completed and we have to start a new chapter. I also had given a few papers for homework. Change the page and this is a new chapter. The name of the chapter is waves. So take a new page and give the new heading. So now look at this point. Wave is a disturbance which move and wave is a mode of energy transfer. So what is the first concept of this chapter? Wave is a phenomena of energy transfer. Anything which transfers energy without the a transfer of mass, this is a phenomena of wave. So when we are talking to each other, we are listening something, we are watching something. This is all a phenomena of wave. So wave is a mode of energy transfer. So copy the, sorry, give the heading introduction. And copy this. So we make our first concept here. And the concepts say that wave is a mode of energy transfer. Now, this animation gives a very good idea that a drop falls on water and water produces a wave. This wave moves. Now, this is a mode of energy transfer. It does not transfer mass. It actually simply transfers energy. Now, give the heading Basic Classification of Waves. There are two types of waves, mechanical waves and electromagnetic waves. What are mechanical waves? Mechanical are those waves which cannot transfer without a medium, like water waves are mechanical. Electromagnetic waves are able to pass through vacuum, so they are called electromagnetic. So now you have to copy this. The mechanical waves need a medium to travel like water waves. Electromagnetic waves are those which can travel through space. They do not need any medium. They can travel on their own. Now we put our second classification of waves. So give the heading, second classification of waves. Look, the second wave, second classification. There are two types of waves, transverse waves and longitudinal waves. There are two types of waves. So now give the heading base second classification and copy this. There are two types of waves. Now give the heading transverse waves. So we first put the definition. The waves in which oscillations are perpendicular. Look, this is the idea. The wave energy is going horizontally and the particles are oscillating vertically. This is called transverse wave. You have to copy the definition. Now copy the diagram. Now look at this example. This is a ripple tank and we put a cork and we run the dipper. The cork moves up and down and this is called a transverse wave. Actually, what happens in a transverse wave, every molecule goes up on its turn. This molecule goes up, then it comes back, give the energy to the neighbor molecule. The neighbor molecule goes up, comes down, and give energy to the neighbor molecule. The molecule goes up and comes down, and it gives energy to the neighbor. It actually goes up, and every molecule give energy to the neighbor molecule. Examples of transverse waves: waves in water, waves in a rope, all the EM wave, and seismic S wave. Seismic S is a new topic, and it was introduced in 2022. So now you have to copy the examples of transverse waves. These are the examples of transverse waves, and there are four examples. The fourth one is a new example. Now, what are S waves? S waves, also called secondary waves and or shear waves, are the second waves to hit the seismographs. Under the earth, these waves are always moving, and humans also use them for the research on analysis of underground situation. So this is basically the seismic waves are underground waves, which are the second waves to hit the seismograph. And now you have to copy this. No need to copy the diagram, only the statement. Now, this is a very good animation to understand what is a transverse wave. Look at this. This is a transverse wave. Important terms in transverse waves. Now you have to give this heading. Look at the first one: displacement, distance, amplitude, wavelength, frequency, time period, wavefront, waveform. These are the terminologies used in this chapter. You have to copy this. Let me know once you have copied this list. Now, this is a general list of topics. So we can start it. Number one is displacement. We can do some of them oral, some of them are not required to be written. But you always need a pencil and a ruler for this chapter because this is a drawing chapter. Now, displacement against time. This is the graph. So when a wave is traveling, it actually shows oscillation or vibration. The particles move in this way. Separation from the mean position. So when a particle oscillates, it moves away from the mean position. Its separation from the mean position at any time is called displacement. The first and two are simple. So I'm starting with amplitude. Give the heading amplitude. Amplitude is the maximum distance from the mean position. Look at this diagram. Amplitude is the height of a wave. So when a wave travels, it is the height, like the signal, how much the signal is big. So look at this signal. This is the height of the signal, and we call it loudness also. So for example, in case of a sound signal, the amplitude is the loudness. Look at this. This is the amplitude. Amplitude is the, look, this is the amplitude. Amplitude is the height of a wave. Now, this amplitude is a measure of energy transferred. You have to copy this. Amplitude is the height of a wave. So when you see a wave, the height of the wave is a measure of amplitude. You have to copy this. Give the heading inverse square law. Now look at this inverse square law. Inverse square law means that intensity is inversely proportional to the square of the separation. So when you move away from a source, the intensity of the source decreases. So as you move away from the source, the signal gets weaker and weaker. This is called intensity inverse square law. So for example, you use the router for internet. So as you move away from the router, the intensity of the signal decreases. As you move away from the router, the strength of the signal decreases. You have to copy this after giving the heading, copy this. So when a signal is traveling, the amplitude of the signal gradually decreases. For example, mobile companies install towers back to back because the signal gets weaker and weaker because of this property. Now, number 4, wavelength, lambda. So give the heading, number 4. What is wavelength? Wavelength is the distance between two consecutive identical points, such as two consecutive crests. So this is the new definition. After few years now, they are very regularly updating the syllabus. So wavelength is the distance between two consecutive identical points, such as two consecutive crests. You have to copy this. Now we are stopping here, and we will inshallah continue in our next class. Allah Hafiz.